Good afternoon, everyone. My name is Allie. I'm an educator here at the Aquarium of the Pacific. Thank you so much for tuning in today for our Aquarium Online Academy Summer Kids Club. Our young scientists here today, ready to talk about coral and conservation. Now, we're going to be talking a lot about different things about the reef and maybe some animals that live in it as well. But if you do have any questions or comments or anything you'd like to share with us, you're more than welcome to text on in. It's this number right below here. That's 562-286-1838. Please let us know. We definitely love your feedback. My friend Talia will be over at the computer taking all of your questions. And of course, my friend Kaya is behind the computer here controlling all of these awesome things you see behind me. Now, if you're watching this and we are not live, that's okay. If you do have questions, because you can just email us. You can email us right at this email address below here. That's live@lbaop.org. Alrighty, so we are going to be talking about coral reef today. Coral reefs and conservation. So let's take a moment and just kind of observe our reef. Now, behind me is our tropical gallery. It's actually it's our largest exhibit. It's about 350,000 gallons, well over several hundred individuals in this exhibit you see here. And this is modeled after a real dive site in Palau. Now, this is a dive site called Blue Corner because if you look over to this side here, if you were able to see it, you would see a big blue wall, and that represents that big blue corner at the actual dive site here. And it's really awesome because this coral reef really brings in some tiny animals and some pretty big animals. So take a moment. What do you notice? What do you notice about the coral reef? Well, I noticed there's lots of colors. We actually just recently put in some new coral here. Now, I want to take a moment and actually let you know that this is not live coral. This is actually artificial coral or a replica. Now, we don't use real coral here at the Aquarium of the Pacific because of conservation purposes that we will hopefully get to in a little bit. We do, however, have some smaller exhibits that is real coral that we can actually grow or have gotten from a variety of sources and can grow, but on this large of a scale, it's a little difficult. So this is all actually artificial coral. So when I say we put new stuff in there, it's kind of like a screw almost that we put in here. Our animals don't seem to mind. They might not even know. They still use it in all the same ways they naturally would. But one thing you can see is just the variety of animals. You'll see, oh, there's a cow nose ray here. There's a eagle ray here. There's lots of little fish all around, even some sharks. And if you look really close, there's a turtle in here somewhere. Can't promise, he sleeps a lot, that he'll come up, but hopefully we'll see here. Now, let's talk a little bit about coral. So you made some observations about this coral, what a coral reef looks like. There's a lot of things going on. Now, let's kind of go down to the basis of what is coral? What does it look like to you? Again, coral is all the stuff that's not moving. So it's all of this stuff on the rocks here and also coming out of the sand. Now, is coral a plant? It kind of looks like a plant. It kind of looks like lettuce right here. Yeah, kind of looks like a plant. But it also kind of looks rocky, doesn't it? Little rock structures almost. You can see around here. Well, it's actually neither. It is, in fact, an animal. Woo! You might have already known that, but yes, coral is, in fact, an animal. It is a cnidarian. So what that is, it's a group of animals that include coral, jellies, and, oh, perfect, just like this nettle right here. So sea jellies, or you might call them jellyfish. And then also sea anemones that you might have actually touched here at the aquarium or seen in a tide pool before. So all of those are included under that cnidarian. That's that main grouping. And they all have something in common. We definitely know it from jellies, but it is that they have stinging cells. Corals sting. Yeah, they have tiny little stinging cells. Sometimes if we touch it, we can't really feel it too much, but they are able to sting small things in the water. Now, coral, again, is a tiny, tiny little animal. So this hard stuff that you're seeing here isn't quite the animal itself. Corals do something to create almost like an apartment building around them. They create a skeleton, an exoskeleton, so a skeleton on the outside, made out of calcium carbonate. You might have heard of that before. It's very hard, similar to a rock. And they have little polyps inside of there. So I actually have some skeletons over here in my document camera that we can go check out to show you exactly where those corals live. So let's go check this out over here. All right, so here are 3 different species of coral. Now, there are hundreds of different species of coral. We definitely don't have time to look at all of them today. Plus, there's new ones being discovered all the time. So it's actually pretty cool. Now, this is a couple examples of coral, but I'm going to go ahead and zoom in. This one you can see really well, so I'm going to kind of move this around. And let's go ahead and zoom in a little bit. Now, what do you notice about this coral? Let me turn up the light a little bit for you. What do you notice? Well, it's very hard. You can see it's not really squishy. But what do you notice inside? There's lots of little holes. Now, believe it or not, each of those little holes is where a polyp would be. So a polyp is pretty much a sea anemone shrunk down. Really, really small. So it has all those tentacles up, and it's like an upside down jelly. And it's all in these holes right here. So you can see some of them are pretty small, and they can create actually huge, huge structures such as these. You can see sometimes their calcium carbonate is a little different. Look at that pattern. That's actually really cool. And there's some that have like almost little lines as well. All right, so we looked at where those coral polyps live inside those little holes there. And there are a couple different categories of corals. Now, there are hard corals and there are soft corals. So hard corals, again, really hard structures, they take a little bit longer to grow. Why would you think that they take a little bit longer to grow? Yeah, making them a little more sturdier. So they take a little bit longer to grow. They maybe grow maybe about a couple centimeters a year in good conditions. So that's kind of the extent of how fast they grow. But they're really strong. So if a big wave comes or maybe a big storm, they're pretty good at withstanding that. And then there are soft corals. Now, soft corals, you can tell by their name, they're softer, so they might not be able to resist kind of a storm quite as well, but they grow faster. So it's a little bit of a trade-off there. It's how much you put in, how much you get out of it. So growing fast, but means that you're a little weaker, whereas growing slow means that you grow a little, or much more sturdy. So let's talk about feeding for these guys, because we mentioned that they are animals. So what are they eating? Animals must consume something. So if we took basically a microscope and went all the way down to live coral, and we looked at it, we would see this. So in each of those holes we just saw over at the document camera, there is a little polyp inside. So these tiny little things, again, very small, definitely need a microscope to look at. But let's see. What can you notice about how they might feed just by looking at them? Yeah, it looks like, see Miss Kaya saying, looks like they have tentacles. They have tentacles. Exactly, they have tentacles that are coming out in the water. Now, they typically come out more at night to kind of feed in the water. So they're a little more protected during the day and a little more tucked in. But they can feed on particles in the water. And they can take those little plankton out of the water, whether it's little tiny zooplankton, animal plankton, or whether it's tiny little phytoplankton, they can take some of that out of the water and consume that. Now, that does it for a little bit of their diet, but if that's all they did, corals wouldn't be too good at surviving because they have something else that helps them feed even more. Does anyone know what that is? It's something they have inside of them that isn't actually a part of them. They host inside zooxanthellae. Have you ever heard that word before? It's a little hard. We'll say it all together. Zooxanthellae. Zooxanthellae is an organism that is photosynthetic. So what does that mean? You've heard of photosynthesis. That's when we take carbon dioxide and water. In the presence of sunlight, we create sugar and oxygen. So that's essentially what they're doing. Just like plants on land, algae is very similar to a plant. They use photosynthesis to create food. So they are actually creating food for the coral, the animal, the polyp itself. So that's actually partly why their corals are kind of found in fairly shallow waters. Most of the time, they're found where light can actually penetrate the water, because the zooxanthellae does need light in order to create that food. So most of their food comes from that zooxanthellae there. All right, so let's go ahead and talk about reproduction. Now let's talk about reproduction for our corals. Our corals, how do they reproduce? Now it doesn't look like they really lay eggs or have live birth or anything like that. No, what they do is primarily they clone themselves. So they are that's what's called asexual reproduction. So there's no gametes involved at all. It's just that single organism that kind of splits itself in half and colonizes and creates a huge apartment structure, huge apartment buildings where all of the tenants in the apartment are the same. So they actually create nice big structures just by cloning themselves. But if that's all they did all the time, there wouldn't be any genetic diversity. So they are able to reproduce sexually as well. Most corals, not all, but most, have both eggs and sperm inside of them. So they're able to release that into the water column, and all of the corals kind of go at one time. Most corals don't do it very often, maybe once or so a year. And it's very easy to predict based off of the water temperature, the moon, and the sunset. And so all of these corals go at one time. And once one goes, they all start going as well. And then they're able to have their eggs and sperm in the water, and they can fertilize in the water column there. And then the coral needs to look for a home. So it drifts, and it's a little tiny larvae that is swimming through the water. It's still plankton, can't really swim, if you will. It kind of drifts through the water. And it wants to pick a really nice spot because it can't move. You'll see these corals, are they moving too much? No. So it's kind of like, all right, I got to pick my house right now while I'm a baby, and I have to live there the rest of my life. So they are pretty picky about where they settle. And then once they settle, then they can clone themselves after that. So why are coral reefs so important? I'm sure you've heard about coral reefs before and how important they are, how much they need our help, but why? So go ahead and text in your answers if you've heard of anything you wanted to share about coral reefs. We'd love to hear from you. Again, our number is right below here at 562-286-1838. We'd love to hear, hey, what do you know about coral? What have you heard about coral? Now, coral is very important because about 25% of the animals in the ocean, so that's about a quarter of a pizza, so a pretty big chunk, rely on the coral reef. So that's a lot of animals that rely on the coral reef. But let's take it a step further. Less than 1% of the ocean is coral reef. So 25% of the ocean depends on a little tiny bit of the coral reef. It's actually most biologically diverse ecosystem in the entire world. even compared to rainforests. It is definitely diverse, and you'll see a lot going on here. Well, again, we'll talk about a few of those animals here in just a couple minutes. But besides being important to the animals that live there, it's important for other reasons as well, such as fishing. Yeah, so some of our food, or in different places around the world, some of the food might come from a coral reef. It's also important for jobs. It's also important for tourism. It's also important for helping our land stay safe. So I mentioned, sometimes storms come and go right on over the reef and come towards land. Well, this can actually slow down a storm a little bit. So if there's reef surrounding that, then it's a pretty good way to kind of calm that storm down before it gets to land. Now, there are a couple of animals in here that I definitely want to talk about just a little bit. Again, these are the tropical animals right behind me here. Coral does like pretty warm water, but not too warm. So we'll touch on that here in a few minutes as well. But this is actually home to a very cool animal, and it has kind of a funny name. It's named after a bird. Do you know what animal I'm talking about? Ah, yes. It is the parrotfish. Is that what you were thinking? Yeah. This is the parrotfish. Why do you think it's named after a parrot? Well, it's actually because of this beak right here. Now, how does this parrotfish rely on the coral reef? How is it involved there? Well, definitely uses it as its home. Oh, I want to point out, this is our brand new webcam that we have here at the Aquarium of the Pacific. This is live right now, just as our other one was, but we just put this one up with our new exhibit here with our awesome parrotfish here. That's that really colorful rainbow one here. So if you would like to check that out, you can check it out anytime on our website or on explore.org. So our parrotfish here, you can kind of see, once he brings his head down just a little bit, they have a beak. So they have a really hard beak. They have hundreds of teeth that have fused together. So it creates this nice, hard beak. Again, why? Why do they have that beak? Well, let's think about what they might eat. Now, parrotfish are what we call herbivores. Herbivores primarily feed on plants, or in the ocean, algae. So these will swim along the reef and they will scrape with that beak. They'll scrape the algae off of the corals. So they will go along and scrape all of this coral here. Now, here at the Aquarium of the Pacific, like in this exhibit right behind me, we don't have live coral in here, remember when we were talking about before? So our parrotfish, we actually put something in there for them. We put this. Now, it doesn't look like much. This is just a white square, a white cube, but it's made out of plaster. And that plaster actually kind of mimics the coral in a way. And so our parrotfish can actually go munch at this to kind of scrape it off. And that kind of helps them to be a little more comfortable in their habitat, because they can't do it as much to the artificial coral. So we have this in there for them as well. I just wanted to point that out in case you were wondering here. But another way that parrotfish are classified, besides herbivore, is kind of funny. It's kind of in between. They're classified as also corallivores. Corallivores. Any idea what that might mean that it's consuming? Coral. Yes, exactly. So when they're scraping off that algae, that's what they want. That is their primary goal. But when they're scraping it off, they do scrape off some of the coral. Now you might be thinking, oh no, we're talking about how important coral is, and now this fish is coming in and scraping it off. Well, it's actually creating room for new corals to settle, and it can take off some of the corals that might not be doing so well. And also, again, it's removing that algae. And when it removes the top of the algae all over the coral reef, then more sun can get into the zooxanthellae, which means more food, which means a happier reef. So parrotfish are actually doing the reef a really big favor for everyone that lives in it by scraping off all that algae and some of the coral. So coral, they don't want to eat that little polyp inside, that little animal, because remember, they're herbivores. They're scraping off the coral, they're digesting it, but they're not really using it. So we should say. So they have all of that polyp kind of go on in them. They have the algae, but then there's that hard calcium carbonate skeleton. I mentioned that it kind of feels like a rock. Would you want to eat a rock? Probably not. So parrotfish are actually really well adapted to this. And that is that they are able to crush it up inside of their bodies and poop it out. Now, if I took a big rock and I crushed it up into tiny little pieces, what would it look like? It would look like sand. Yes. So all tropical beaches and such white sand. Congratulations. That is now parrotfish poop. So they can actually, each parrotfish can make around 200 pounds of sand every year. And that's just for one parrotfish. So they create a lot of new sand, which is also really beneficial for other animals as well. But that's a really cool thing about the parrotfish. They're creating new space and creating new sand by just kind of scraping off those the algae there. So it's actually another cool thing. These guys, they like to kind of make a mucus layer around them while they sleep. So the parrotfish, when they want to go to sleep, they kind of go into the reef a little bit. Look at it. He's just kind of checking itself out in the camera there. You can get a pretty good view of those fused teeth right here. Oh, that's an excellent view. So they create a mucus layer every single night. Now, it's kind of hard for them. There's a lot of energy involved when they're making that mucus layer. So it has to be doing something for them. So what it's doing is actually protecting them at night. So when they crawl or swim into a little cove or out cave here in the coral reef, they'll make that mucus layer all over them and they'll go to sleep. Now, it doesn't look like they're really sleeping too much because they don't have eyelids, so it just looks like they're awake. But they're coated in that mucus. And that mucus helps to prevent against parasites. So just like maybe if we were out camping and there's mosquitoes or little bugs, might come bite you, might not like that. Just like that in the ocean. But that mucus layer helps protect them from those little critters there, those little parasites. But also it helps them to kind of conceal their smell. Now, why would you want to conceal your smell? Yeah, so if something was swimming by and it smelled you, it could be like, perfect. I know there's a fish in there. That's a perfect snack. But if they can't smell you, then they might not know you're there, and then you're a little bit safer. So that is definitely one of my favorite animals that live on the reef. But I do want to talk about how the reef needs our help. Now, we talked about how important our reef is. We talked about how 25% of the animals depend on this habitat right here. How tourism and jobs and food and protection against storms, that we do really depend on this habitat. Now, unfortunately, this habitat isn't doing very well right now in our oceans. Now, why do you think that is? Well, a lot of it is actually from the warming of the water. Now, I know this is tropical, very nice, warm water, but if it gets too warm, then that coral isn't very happy. So I believe this exhibit here that we are looking at here at the Aquarium of the Pacific is kept around in the high 70s. But if, our whole planet gets really, really warm and the water heats up even a couple degrees, we might not even notice it, but they do. And when they notice it, guess what they do? They say, bye zooxanthellae. Zooxanthellae, again, is that little photosynthetic organism that it has inside of it. And it goes, phew. Nope, all those zooxanthellae go on out. And I mentioned that they're the main food source for a coral. So if all the zooxanthellae head on out, well, the coral is kind of left like, I can't eat enough. And that's when they kind of look white, like those skeletons I showed you a moment ago. That is called coral bleaching. And if water temperatures return to normal within a pretty quick amount of time, give or take, then those zooxanthellae can come back and the coral reef could be happy. But if they don't return to normal, which is unfortunately most of the time, then the whole coral reef is bleached, and that means that it has died. All of those coral polyps weren't able to make it. All of the zooxanthellae has gone away, and if all of our corals are gone, well, do you think these animals would be here? No. So it's actually pretty destructive from a ecological standpoint. Just having that base of that habitat destroyed really does affect animals all the way up to even some of our big sharks. So coral really does need our help, not only because of warming temperatures, but also because of ocean acidification. That's a big word, I know, but acidification means that it is becoming more acidic, which means it kind of dissolves things a little bit. So all of that calcium carbonate that they're making those hard skeletons out of, well, they don't have access to as much calcium anymore because that calcium is being basically dissolved away. So they can't make very strong homes, which means that they are more prone to breaking, more prone to not making it or being kicked off or something like that. And again, that could really harm our ecosystems. But other animals, like animals that have shells, oysters, clams, even things like crabs or lobsters, they use that calcium carbonate as well, and they are getting much softer shells. And if a clam gets a much softer shell, it doesn't grow as big, it's not as protective, it actually, because it doesn't get as big, doesn't have as many babies, and then of course that could be an issue as well. So here at the Aquarium of the Pacific, what are we doing about our coral? Well, out in the ocean, again, we can't be there right at every single reef to help out, but there is an organization called Seacorps, and we do partner with that nonprofit organization, and they mainly work out of Guam and Palau, and researching how to build reefs. So what they do is they go and they capture the eggs and sperm from spawning corals. I mentioned that it's pretty predictable when a coral will spawn. So they can go there when they know they're about to, collect those eggs and sperm, bring them back to the laboratory, and start growing them on tetrapods. So I have one over here. And we also have a nice picture of one. So yes, this is this tetrapod right here. And this is the start of little corals. So Seacorps actually grows tiny little corals and under a laboratory condition. And the goal is to then put this kind of funny looking shape back into the reef to then help to replenish the reef by asexual reproduction, as well as hopefully sexual reproduction one day, but asexual reproduction as well. So that's the goal behind Seacorps, is taking those eggs and sperm from the water, helping them out a little bit by letting them settle and grow a little bit before they are put back on the reef. So it's an excellent organization. If you do want to check out more, I encourage you to look at seacorps.org. It's really great to see how different organizations and different nonprofits are going about helping our coral reef. Because even though here in Southern California, we don't have coral reefs, well, it still affects us in some way, depending on, doesn't matter where you are in the world. Alrighty, well, thank you so much for hanging out with us today. We do have a take-home activity for you. It is a little bit of coral reef observation. So right on our website, right underneath, I believe, this link right here, there'll be another link, and there's a take-home activity that you guys can kind of check out, see if you can make any more observations about our reef. And we will see you back here again at 1 tomorrow for whales and conservation. I think your theme this week for Summer Kids Club is conservation, so should be a lot of fun. Anyway, thank you so much. Have a great rest of your day.